In this review video, we're going to be reviewing factoring. And factoring is one of these things that when you start out doing it in like algebra or algebra 2, it's a little difficult, but you really want to get to a point where you're not straining a lot to do factoring. You want to be able to do it pretty quickly because it's going to make pre-calc and calculus that much simpler. If you have to do like a 10-minute process every single time you have to factor a problem, then it's not really going to be attainable to finish pre-calc or calculus because you're not going to be able to get to the more complicated things. All right, so we really want to make sure we're like mastering factoring completely this semester, so when it comes up next semester in pre-calc or calculus or any of that stuff, you can just do it from your memory. Before doing factoring, the only thing you have to be kind of aware of is if you multiply powers of x, you just add those two exponents. If you were to divide powers of x, you subtract the two exponents. Pretty much if you know that, then you can do factoring. All right, so in dealing with a big, difficult expression, it's helpful to break it up, the expressions, into smaller pieces. And we have to do this if we're trying to use solve equations and things like that too. This process is known as factoring. So just like if I had like 15, I can break this up into a 5 and a 3. Breaking up into smaller pieces, these are more manageable pieces than the big 15. Factoring is the same thing, you're just doing it with an expression instead. All right, so we've learned two types of factoring. Factoring the greatest common factor. We call it the GCF. Greatest common factor, that just means there's something that all of our terms have in common. And that thing that we have in common, we can just pull those out, factor those out to the front, and leave behind something simpler afterwards. And GCF factoring is always what you kind of start. Can I make everything smaller by doing the GCF? The second thing we learned was factoring quadratics. That's things that look like this. And the method we learned for factoring is called the splitting method. We're going to go over this in the video, but it's really important for this one. Normally I'm like, oh, you don't have to know the name of this thing that we're doing, you just have to know the process, but knowing the name splitting method kind of reminds you of one of the important steps. So that's why I kind of always mention it's called the splitting method. All right, so here's our first example. We're going to factor 15x squared minus 2x minus 8. And the thing with these review units is I'm not necessarily going to tell you which method you're going to be using, so you're going to kind of have to analyze and like, okay, I have these two different methods, which can I do? So the first method is greatest common factoring. So I ask myself, are there any things that all these have in common? Well, my first term has two x's, x squared. My second term has an x, but my third term has no x's. My first term has a 15, which is divisible by 5 and 3. My second term has a 2, which is only divisible by 2. So there's no numbers that divide all the numbers that don't have any x's all in common, so there's no GCF. Well, I guess you could say the GCF is just 1. All right, and if it's 1, that doesn't really change anything. So now, option 2 is the splitting method. Right. And the splitting method says this. I want to add, let me erase this stuff real quick. I want to add to the middle number. So I'm going to add to -2. And I want to multiply to a times c. So a is the number in front of x squared, c is the number there, 15 times -8. I'm actually pulling up a calculator. It's what? 120? -120. That was right. All right, -120. All right, so now my goal is to find these two numbers that at the same time multiply to -120 and add to -2. I already know what the numbers are because I made the problem, but how would you do that? Well, I always start off with 1 and 120. All right, those aren't going to work, so now we'll try 120 divided by 2. That's 2 and 60. Divided by 3, 3 and 40. Divided by 4, 4 and 30. Divided by 5, 5 and 24. Divided by 6, 6 and 20. All right, so I'm just going problem at a time. 7 gives me a decimal, so it doesn't work. 8 and 15. 9 doesn't work. 10 and 12. And 11 doesn't work, and the next one's 12, but 12 I've already gotten in my other column, so I'm done. Once you kind of work your way around to the other column, you're done. And now I want to multiply this to -120, so I'm multiplying to a negative. One of them should be negative, and since I want them to add to a negative, the bigger number should be negative. So which of these pairs is going to work? It's the very bottom one, 10 and -12. All right. So now I have my pair of numbers, and now here's where we remember it's called the splitting method. Why is it called the splitting method? Because I take this middle number and I split it up into these two numbers. So I'm going to write 15x squared. Instead of minus 2x, I'm going to write plus 10x minus 12x minus 8. And notice because this had an x in it, both of these have x's too. I'm just splitting that term, that x term, up into two separate x terms. And the reason we do that is because now, since we have 4 terms, I have these 2 different groupings. And within those groupings, now I do greatest common factor factoring. So 15x squared plus 10, 5 divides both of those, and they both share an x. All right, when you're factoring something out, you're kind of dividing it out. So 15 divided by 5 is 3. X squared divided by x, I'm canceling out one x, so there's still an x left. 10 divided by 5 is 2. And the x divided by x completely goes away because it's 1. Right, minus 12x minus 8, they're both negative, so I can factor out a negative, and they're both divisible by 4. And that leaves behind negative 12 divided by negative 4 is 3. And I didn't do anything with the x. Negative 8 divided by negative 4 is positive 2. And now I have this 3x plus 2. That's the same, and that's really the main goal. And when I get rid of 3x plus 2 at the front, what's left behind is the 5x in the first term and the minus 4. All right, so that's our factored form for this quadratic. And that's kind of a quick review of the splitting method. And in this problem, we want to, again, always start off with our first thing is finding the GCF and see if we can pull something out. So we look at kind of the numbers and the variables separately. So we have 6, 12, and 9. Well, the number that divides all those, the biggest number that divides all those is 3. We have a cubed, a to the 4th, and a squared. I generally just going to pick the lowest power, in this case a squared, because they all share that many a's. And then b to the 4th, b to the 6th, b to the 7th. The lowest one is b to the 4th. Again, it guarantees they all share that many b's. All right, so what's going to be left behind if I pull that out? 6 divided by 3 is 2. A cubed divided by a squared, 2 of the a's cancel out, there's 1 left. B 4th over b 4th fully cancels out, there's none left. 12 divided by 3 is 4. A to the 4th over a squared, 2 a's cancel out, so there's 2 left. 4 b's cancel out, so there's 2 left. 9 divided by 3 is 3. All the a's are gone because a squared over a squared. B to the 7th over b to the 4th leaves 3 b's behind, b cubed. And whenever you're doing GCF factoring, you always want to check to make sure that there's nothing in common between all of them. These two have an a, but this one doesn't. These two have a b, but this one doesn't. These two are divisible by 2, but that one's not. So that means you factor out the greatest common factor because there's nothing left in common in those parentheses. Now a good habit is say, okay, I pulled up the greatest common factor. Is there anything else I can do? And no, because there's all these different variables hanging around. There's nothing I can do. This is the final answer. Example 3, again, first thing I should always do is find the greatest common factor. I see right away all these terms have an x in them. So I can pull an x out. And then 3, 12, and 36 are all divisible by 3. All right, so I can pull a 3x out. And that's going behind a 1x squared, a minus 4x, and a minus 12. Right. So now this is as simple as I can get, but this looks similar to something that we did in the first example. So we're going to say, can we do the splitting method here? We would have to add to negative 4 and multiply to negative 12. Is that possible? It is possible if I choose negative 6 and positive 2. So there's going to be 3x. It's going to hang out. And this is one of the things, you could kind of do this to the side, or you could do it in the parentheses the whole time. Let's just kind of do it to the side. Right, so we're going to have x squared minus 4x minus 12. We're going to do the splitting method. At my first pair, I factor out just an x, because that's all they have in common. My second pair, I can factor out just the 2, because that's all they have in common. And then the x minus 6 is factored out and leaves behind that x plus 2. Right, so that's going to be the rest of my answer. Okay. Right. Again, you could keep all of this and like work it out with the 3x in the front the whole time, but you kind of might forget the 3x at some point. I think that 3x contributes to everything else you're doing. So it might be easier just to factor this quadratic to the side and then kind of input the factored form there at the end. All right, so there's one expression up here, simplifies to these 3 different things being multiplied. There's one kind of special factoring thing we learned. I'll show you a trick that you won't necessarily have to know this, but it's a really common thing to come up if someone's trying to create a problem that's like, oh, we can factor this really quickly. They're going to give you this, which is called a difference of squares. It's one thing perfectly squared minus another thing perfectly squared. And the pattern is Just the exact same expressions. One has a minus sign, one has a plus sign. All right, so if we look at this expression, x squared minus 16. All right, you could factor this using the splitting method if you write it as x squared plus 0x minus 16, right? That gives you that middle term, that x term that's missing. So you could always just do that and factor using the splitting method. But this method's a little bit quicker because x squared is x squared. 16 is 4 squared. And if I have these two perfect squares, this turns into x minus 4 times x plus 4. It's the same answer you'd get using the splitting method, just a lot quicker. All right, 9x squared. 9 is 3 times 3, so that's 3 squared. 25 is 5 times 5. Sounds like this is 3x minus 5 times 3x plus 5. Right. And again, you could have done this using the splitting method if you did this. It just means you're adding to 0. All right, it's just a lot longer process. If you recognize it's a difference of squares, it just saves you a lot of time. All right, with these review videos, again, the main thing is you don't have to do skill checks, but you're kind of reviewing, making sure you go through all those practice problems, really making sure you understand and can do these problems. All right, factoring, again, it's just like a single thing that we learned in this semester, but it's going to make pretty much everything else you do in math a lot simpler because factoring just comes up all the time because these quadratics kind of just pop up whenever you're doing other problems.